All right, so one way to give information about the motion of objects is through graphs. Okay, most people don't like graphs, and I can't say I'm like I disagree with that. I kind of agree with that, but we have two main graphs that we use in physics. There could be a third with acceleration, but the first one is displacement versus time graph. Okay, so we would call it an x versus t graph, and this is a velocity graph. Okay, it's a velocity graph. Why is that? Let's say we have a slope here. Okay, or a line. If we take the slope of this and we go rise over run, the rise would be the change in, yeah, nice job, right? Messed that up. It'd be the change in x over the change in t. Now this might throw you off a little bit because in math class it'd be change in y over change in x, right? But when I say change in x, I'm talking about our displacement over here, which is the y divided by the x, okay? And x divided by t, if we think about meters over seconds, that's velocity, okay? So in this case, the slope of this line is equal to the velocity. So if we have a straight line like this would be a constant velocity because the slope never changes, right? Constant velocity. Now let's say we had something like this. Right? This would actually be increasing. A lot of times students say it's increasing because, it's going up. What I would do is take a ruler and put your finger on the curve, and as the curve changes, what happens to the slope of this pen, pencil, ruler, whatever? Low slope, high slope. So we go from a low slope, that's low velocity, to a higher slope, that's higher velocity. So this would be increasing. Velocity, and then ultimately this would be decreasing because we have high slope to low slope. All right, this over here would be decreasing. All right, now you'd have to think of for yourself what happens if, let's say, it goes down the other side. Right, let's say it went like this all the way around. Well, at the top the slope would be 0, we wouldn't be moving, and then as it goes this way, our slope goes from low slope to high slope. So this would be decreasing, 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 stop, increasing, increasing, increasing. Okay? So it's important to make what we call tangent lines. Tangent lines are basically, and you should have this from math class, it's just a line drawn from a single point. Okay? And we could see that the slopes made by those tangent lines are increasing and obviously decreasing and increasing over here. We spend a lot of time on this in class, but it's kind of hard to do it this way. All right? So that's called a velocity graph. The one thing here about this is that the velocity is forward. Okay? And we can think about that because let's just look at the x here. Okay? X is positive x up here. It's a negative x down here. Positive displacement, negative displacement. So this would be like your starting point right here, let's say. Wherever you're at. Let's say right here. Then we'd be moving away from 0 in the positive direction. We would stop, and then we would be coming back towards the 0 point. Okay? So this all takes place above, in front of where you started. Make it get more complicated than that, as usual, as with everything else. All right, next is, and those are the most important ones really for now, honestly. I'm going to go over this other one. It's the same principle, but it's just with acceleration. So instead of x's, we're going to have v's. And then the slope of our line is going to be the acceleration. So we're going to make the same sort of graph. Instead of x, we're going to have v and t. So v versus t is an acceleration graph. So it's how fast the velocity is changing. So this right here, constant velocity. So the way I look at that, it's not a constant velocity, it's a constant acceleration. People that like cars are not going to like this example, but let's say we have the gas pedal and we just go in just one spot and hold it there. We could say that you get the same acceleration. I know it doesn't work that way, but I think the idea of what we're saying is fine here. What I'm saying is fine. Constant acceleration. Okay? Now, let's say we do this. Okay? So acceleration is based on the slope. Low acceleration, high acceleration. Maybe that would be like you have the gas pedal and you just go, okay? And so you're increasing the rate at which the velocity is changing. And then this one, this should not go down. Let's just say it goes up. We have a high slope, that's high acceleration, and then we have low. That would almost be like you floored it, and then you kind of like started to back off of it. Okay, so you start with the gas pedal down, and then you start to back off it. High slope, high acceleration, low slope, low acceleration. Okay, and graphs could look all kind of different and stuff. Like what would we know about a graph that looks like this? Well, the acceleration's constant because it's a line. Do we know anything else? Well, yeah, we know velocity is also constant, right? Because it stays right at the same one the entire time. Okay, maybe that's like cruise control. You put cruise control on in the car. So there's a paper in the binder that looks at some graph interpretations, and it focuses mostly on displacement, distance, and then time. And if you're looking for the velocity, all you have to do is find the slope in that.